Here I have just a few more examples. These are all nucleophilic conditions followed by an acidic workup second step. But in this case, I've included some stereochemistry to think about. And the thing to keep in mind is this nucleophilic attack is essentially an SN2 step. And when nucleophiles add, they add opposite the side of the leaving group. So if the epoxide's a leaving group, the nucleophile adds opposite it. So in our first reaction, we have NaCN. That's Na plus, and Cn minus is the nucleophile. Look at your two epoxide carbons, and the one on the right is less substituted because it has a methyl, and if you want to draw it in, we have a hydrogen. Okay, now in this case, the epoxide is drawn in the plane. So what I'm going to do is add the nucleophile in the plane, but from the side opposite, from underneath. So we break that open. Let's draw what we get. On the left side, it's not a chiral center, so we don't really care about the stereochemistry there. On the right, I'm going to draw that cyano group pointing straight down because the epoxide leaving group bond was pointed up, so this will do opposite, which is down. And then I have the methyl out, and that methyl kind of gets pushed upwards, but it's still out. And if you want to draw it in, the hydrogen is back. Now this, of course, in step 2 gets protonated. So we protonate the oxygen. And I'm going to leave the hydrogen implied. So there's the final product. In the second example, we still have the epoxide on a chain. But in this case, the epoxide was shown with dashes and wedges. So here the epoxide is on a wedge, and my nucleophile is NH2 minus. Now if you look at this, we have the two carbons of the epoxide, and the one on the left is less substituted. So we're going to add the nucleophile right here. The one on the right, if you just kind of think three-dimensionally, if this epoxide is pointed out towards you, we have this phenyl down. This methyl group, I'm going to put it toward the back. So you don't have to do this, but I think it might make it a little more clear just to put that on a dash to help us keep track of everything. It might seem counterintuitive, but it actually does not matter if you keep the phenyl in the plane and put the methyl back, or keep the methyl in the plane and put the phenyl back and follow through with the stereochemistry. In both cases, you'll get the exact same molecule. And if you don't believe me, try it and assign the RNS configurations. So I just decided to put the methyl back. So now I'm going to take this NH2 minus and add it to the epoxide carbon and open that up. And draw my chain, and on the right side I have this methyl that I put back. The O ends up as O minus, and then it gets protonated to be OH. And then on the left carbon, this now has the NH2 group, but it came in from the side opposite the epoxide. So since the epoxide was out, I want to put the NH2 going back. So there's the product for that reaction. One last example here, we're using sodium hydroxide. So that means OH minus is the nucleophile. In this case, both sides of the epoxide are equally substituted and the molecule is symmetric, so it doesn't matter which side I add the OH minus to. I'm just going to add it right here and break that open. But remember, this adds from the side opposite your leaving group. So I'm going to put a wedge OH here. And then the new OH that added, let's draw it in blue just to differentiate it. It's going to come in from the back right here. So this is actually a way to get an anti-diol.